Hi, I am Dr. Prashant Kumar Vardhan, Professor, Mechanical Engineering Department, GIS College of Engineering, Kollam. My subject topics is Advanced Welding Technology, ME 703A, lecture number 8, Gas Tungsten Arc Welding, GTAW. Gas Tungsten Arc Welding, GTAW. It is also called TIG, Tungsten Inert Gas Welding. These two figures shows how the welding process, tungsten inert gas welding, is performed. In tungsten inert gas, tungsten is a electrode used for the arcing purpose. Introduction. In gas tungsten arc welding, GTAW is called a tungsten inert gas welding. The electric current is created between a non-consumable tungsten electrode and the parts to be joined. As in GMAW, inert gas sealing is used around the arc to protect the weld pool. Tungsten is a good electrode material because of its high melting point of 3410 degrees centigrade. In the case of aluminum, the electrode is sealed, break up the oxide layers on the aluminum sheet surface. Gas tungsten arc welding is also known as tungsten inert gas welding. An arc welding process that uses a non-consumable tungsten electrode to produce the weld. Weld area is protected from atmospheric contamination by an inert sealing gas, that is argon or helium. A filler material is normally used. The tungsten arc welding process is versatile and can be used on ferrous and non-ferrous metals. Gas tungsten arc welding uses a constant current power source. The first industrial application for gas tungsten arc welding began within the aerospace industry and plays an important role in the construction of a ship superstructure and other pipelines joints. In operation, the figure shows how the TIG welding is performed. There is GTAW head, where electrode is there, and another side power nozzle, power one cord is there, or power, another pipeline is sealing gas. Therefore, there's contact tubes and tungsten electrode, non-consumable. Direction of filler rod is there, electric arc, sealing gases. And the copper shoes are on the back side of this sometimes is required for earthing. Working principle. An arc is established between the end of a tungsten electrode and the electrode is not melted, and the welder keeps the arc gap constant. The current is controlled by the power supply unit. Filler metal, usually available in 1 meter length of wear, can be added to the leading edge of a pool as required. The molten pool is shielded by an inert gas which replaces the air in the arc area. Argon and helium are the most commonly used shielding gases. Working principles. tungsten inert gas, TIG welding is a popular type of welding that utilizes tungsten electrodes to join various metals. The fixed welding variables include the type of filler metals, electrode type, size, and the type of current, and the type of sealing gases. The process can be used to weld thin or thick materials with or without a filler metals. When welding thinner materials, edge joints and flange filler metals are not used. For thicker materials, an extremely fat filler wire is generally used. The size of the filler metals wire depends on the thickness of the base metal. In TIG process, the arc is formed in between a pointed tungsten electrode and the workpiece in an inert atmosphere of argon and helium. TIG process is ideal for quality precision works. Equipment used for TIG welding: number one, tungsten electrode, welding machine, constant current, that is AC, DC plus, DC minus, or AC DC both. Torch or electrode holder is the sealing gas supply, helium, argon, or mixture. Filler metal rod, welding arc showing tungsten electrode and the filler rod. It is used separately, tungsten electrode and filler rod. And this is a welding circuit. In welding circuit, two lines, one power lines to the torch, welding torch, another line is to the workpiece. And the power sources, gas supply, sealing gas supply, cooling water in the torch for cooling the torch, and the filler rod is there. Arc is formed, parent metals. This is another performance when the welding is performed. Gas tungsten arc welding is a nozzle. On the nozzle, the non-consumable tungsten electrode is there, and nozzle, one sealing gas is in the pipe, another conduit is current conductor is there. It's put it in the connected with the electrode, that is tungsten electrode, and gas is in the sealed gas nozzle is there for sealing the arcing area. Welding rod guide, welding rod, gaseous sealed, and arc is formed, and under that molten metal is there, and copper backing is there for better control of the arcing. Welding is performed. The tungsten electrode is a critical component in the process as it channels the current required to establish the arc. The tungsten electrode can be alloyed with a variety of metals. One is 2% lanthanated electrode, tungsten electrode, blue color, AC and DC both can be used. The aluminum, magnesium alloy, nickel alloy, copper alloy, titanium alloy are uses with this electrode. 2% thylated red color, only DC can be used, best for copper alloy, nickel alloy, and titanium alloy. Rare earth mix, purple color, AC and DC both can be used. Aluminum alloy, magnesium, titanium alloy, nickel, copper alloys are preferred. 2% serrated gray, DC is used, titanium, copper, magnesium, aluminum alloy. 0.8% zirconated white electrode, tungsten electrode, AC is used, magnesium and aluminum alloy. Your tungsten green color, AC is used, magnesium and aluminum alloys. This is the tungsten electrode. Create the arc for TIG welding. Tungsten properties allows an arc to maintain a temperature up to 6,100 degrees centigrade. Electrode diameter is varying from 1/16 inch to 1/4 of an inch, that is 1.6 millimeter to 6 millimeter. Most critical component of the process is shape of the tip of the electrode. One is pointed tip, welding ferrous metals, rounded and tapered ball end, welding non-ferrous metals. Sealing gases. Argon and helium are the two most commonly used sealing gases used for GTAW. The characteristics most desirable for sealing purpose are the chemical inertness of the gases and their ability to produce smooth arc action at high currents. They protect the tungsten electrode and the molten weld pool from the atmosphere. Gas purity affects a weld. For best results, the percentage of inert gas should be at least 99.9% pure. Argon and hydrogen mixture are often used for welding of stainless steel. Difference between TIG welding and MIG welding. Left side TIG, non-consumable tungsten electrode, which is slowly fed into the weld particle. Let's say MIG uses a continuous fed of welding wire that burns, melt, and fuses both the base and parallel metals together. TIG welding is more commonly used for thinner gauge materials. In MIG, a range of material thickness can be welded from thin gauge sheet metal right up to higher structural plates. TIG welding is slow, fine, delicate welding technique. MIG welding is faster welding is done through MIG. TIG welding is complex, require more skill and costlier than MIG. MIG welding is user-friendly, equipment is more accessible, and are less costly than TIG. Application. Gas tungsten arc welding is most commonly used to weld stainless steel and non-ferrous materials such as aluminum, magnesium, and copper alloys. Aerospace industries uses light metals, aluminum and its alloy, thin sheets, and need high quality welding, so TIG welding is more suitable for it. Use in nuclear power plant. Advantages. The advantage of GTAW includes earthenly low heat input, which offers better control of weld film dilution by the substrate and make it suitable for welding thin sheets. The excellent sealing offered by argon, helium, or their mixture means that the process is very clean. GTAW is slower than GMAW, but the weld made by GTAW have much better surface appearance and require little or no finishing operation, since no spatter is created in GTAW. Advantages. Gas tungsten arc welding can be used for welding on almost any shape of metals. GTAW allows the welder to maintain a higher degree of control over the welding pool. Gas tungsten arc welding gives extremely high quality results under the right conditions. GTAW results is little to no spatter, making it one of the cleanest welding processes. GTAW can be performed with or without feeder metals. GTAW allows good control over various variables such as temperature, creates strong joints. Disadvantages. GTAW often has higher cost. GTAW requires a highly skilled, experienced welder to perform. GTAW has lower deposition rate when compared to some other welding processes. Lower melting point material cannot weld by this method. GTAW lower welding speed, not easily portable. Thank you.